Okay, we are going to start. If you have any sound issues on your side, you can write them on your chat window, and the coordinators of this meeting are watching, are keeping an eye on it, and they will try to answer any questions via chat. Also, in terms of organization, we, because of the large number of participants, many more than we expected. We expect over 200 participants. We are going to be running the seminar strictly in two parts. During the first 45 minutes, I will give the presentation, and then after 45 minutes, we will open the floor for questions. At that stage, when I say that we open the floor for questions, then you can type questions on the chat window, and I will be seeing them in front of me, and I'll be able to reply them as we go. So that is for the logistics of today's webinar. Welcome everybody to this webinar on process mining and predictive process monitoring. My name is Marlon Dumas. I am a professor of information systems at the University of Tartu in Estonia and co-founder of Apromore, an open source process mining solution provider. And this is a webinar organized by the InnoCape project, which is an EU-funded project. The purpose of the webinar is to give you give you three things. The first thing is I would like to answer the question of what is process mining. So first, I will focus a lot on the what, on the technology. Secondly, I will talk about why we use process mining, what are the business benefits of process mining, and I will introduce a framework for structuring, for thinking about the value of process mining called value-driven process mining. And at the end, I am going to give a demonstration on a real data set of how you can achieve this different, or you can tap into the value of process mining. And at the end, we are going to have time for questions. So first of all, it's very important to place process mining in the broader context of business process management, because that is what it is part of. So the objective of process mining, like any other BPM technology, is to improve and manage business processes in an organization. And this is done by means of many different activities. In our textbook on fundamentals of business process management that we co-authored with a few colleagues in Australia, Austria, and the Netherlands, we proposed a life cycle for managing business process improvement projects, which starts by identifying and scoping processes, which gives rise to a process architecture. Once you have scoped your processes that you want to improve and you have attached performance measures to them, you discover those processes in details. That leads to what we call as-is process models. And you start analyzing those business processes using data from a variety of sources. And that gives rise to discoveries of insights and weaknesses of the processes and their impact. Then, based on those weaknesses or opportunities for improvement that you have identified, you apply certain methodologies to redesign your process, and that leads to a to-be process model, which is what you will then implement in an information system. And implementation means changing the way the work is performed, and possibly also enhancing the information systems that support your business process. Those information systems record in transactional databases a large range of information, a very wide and rich set of information. That information that you collect while you are executing the processes can then be used to monitor the process and to adjust it in order to achieve your performance objectives. And that is the phase of the BPM life cycle that we called process monitoring and controlling, or simply business process monitoring. Business process monitoring is about taking data from the database of an enterprise information system. And this could be any type of system. It could be a customer relationship management, CRM system. It could be an enterprise resource planning system. It could be a specialized enterprise information system, as we find, for example, in the insurance industry, such as Guidewire. Or it could be any type of cloud-based enterprise system. From the databases of these systems, a subset of the tables contain records about business objects that are being manipulated by business processes. For example, in an ERP system, you will find records about everything that happens to a purchase order throughout its life cycle. When it was created, when it was approved, when it was sent to the supplier, when the supplier replied, when the delivery happened, when the invoice arrived. All of that will be recorded in the enterprise system. Those records, we can extract them into so-called event logs. An event log is all the data you have about a given process. Or we can stream it in real time via event streams into and produce from there generally two types of artifacts. One of them is performance dashboards, and that is provided by so-called process performance management tools. Or you can produce different types of process-oriented visualizations by means of a family of techniques that we call process mining. So if I summarize, our objective is to improve processes through a BPM methodology. As part of that, we need to monitor the processes that we are executing. That happens by extracting data from a database into an event log and using a variety of techniques, including process mining. It's very important to keep that broader context in mind. Now, very important is to understand what is an event log, because that is the starting point for any process mining effort you do. So if you have the type of data that I will describe, you can do process mining. If you don't have the type of data that I will describe for your process, then you first have to retrieve it, and then you can undertake process mining. So an event log, which is the starting point for a process mining analysis, is as a table. Like you can see it as an Excel table or a data frame, we call it, in which every row denotes the execution of a business process. Sorry, the execution of a step in a business process. And that could be receiving the purchase order, approving the purchase order, revising the purchase order, anything that happens to the purchase order. Here I am showing an event log, a simplified event log of a loan application handling process in a bank. In this process, there are activities, and I need to have a column in my table, in my event log, corresponding to the activity. For every row, I know which activity or which step in the business process has been performed. Check completeness, check credit history, calculate credit risk score. For every such step, I also need to know when it happened. So I need to have a timestamp for it. At least one timestamp. If we have more timestamps, two timestamps is even better, like the start and the end is even better. But even if we only have the end timestamp or only the start timestamp, we can already do certain things with process mining. And the third thing we need to have is an identifier of the instance, the process instance in which this step happened. That can be, in the case of a loan application handling process, the loan ID. So this will be the loan application ID. So for every loan characterized by its ID, I will have a sequence of steps that have occurred in some order. And an event log will have, say, thousands or even in some cases tens of thousands of such cases within the same event log. The more you have, the more analysis you can do, because you can, for example, do analysis over time, longitudinal analysis. In addition to these three attributes which are compulsory, you can have other attributes. For example, here I know for every step who performed it, the resource. I have also some domain-specific attributes. For example, this is a loan application handling process, so one of the domain-specific attributes in this field is the purpose of the loan, or the requested amount of the loan, or the offered amount of the loan, etc. So I might have typically 10, 20, 30, 50 attributes corresponding to different aspects of your business objects, which are determined by the domain in which you are operating. Given this, an event log that looks like the one I just presented, process mining allows you to perform essentially 4 types of operations. The first operation is called automated process discovery. And automated process discovery means that from an event log, I can discover a process model of it. The second one is, so for example, from this event log here, I can discover different types of process models. The simplest type of process model is called a process map. It's a boxes and arrows type of diagram. The box represents a step in the process, and the arrow represents that this step happened right, the second step happened right after the first step. And you can annotate it with all sorts of metadata. The second type of models that I can derive from a typical process mining tool will be BPMN process models. And for those of you who are familiar with process modeling and process management, basically BPMN is a standard language for representing business processes, for documenting business process diagrammatically. And what's important is that to derive this process model, I didn't need anything else than an event log with at least these 3 columns: the case ID, the name of the step, and the timestamp. And there you go. With that, the process modeling tool will give you the process model at any level of details you want it. The second operation that a process mining tool provides you is conformance checking. Conformance checking means that I take as input not only an event log, but also a process model. And I check the event log, the process model, against the event log, and the tool will tell me whether they match or whether there are discrepancies. And why is this important? So if I have a process that is quite normative, like in a loan application handling process, where I need to perform certain steps, and these steps must be performed in a certain order, it is important for financial institutions to then check that in reality, we are following the process. If we are not following the process, compliance managers need to be aware of, and these deviations with respect to compliance rules need to be investigated in order to determine if they are hindering compliance against regulations or not. For example, this is a process model of the same loan application processing handling system log that I showed you before, and this is a compact representation of the event log. I represent the tasks by letters A, B, C, D. So A, B, C, D, H. H is a trace in the process. It's a sequence of steps that happen for one particular loan application. This is another loan application, and so on. I take an event log consisting, say, of 6 such traces, different traces, and I can check if they match the model. And a process mining tool that supports conformance checking will be able to tell you 2 things. First, it will find what we call unfitting behavior. It will tell you, look, there are some cases where this task is not being performed. According to the process model, because I have a parallel gateway here, this must always be performed. But in some cases, particularly 2 cases here at the bottom, it is not being performed. The second type of diagnosis that conformance checking will give you is called additional behavior. In here, I have a loop that is captured in my process model. I had contemplated that this could happen, but I don't see it in an event log. So I can wonder, why is it that in principle, it is possible to have this back loop, but we are not observing it in reality? Maybe there is something in the information system that is preventing people from executing certain steps that they should be able to perform under certain conditions. And then I can investigate that further and find some more detailed diagnosis and improve my business process accordingly. The third type of operation that a process mining tool will provide you is what we call performance mining. Performance mining means I take an event log and I take a process model. And the process model can be a process model that I design myself manually, or it can be a process model that I discovered automatically from the event log. So sometimes I discover the process model, and right after that, I mix it up with the event log to come up with a so-called performance enhanced process model. And in a performance enhanced process model, it's like a process model, as I showed you before, but it's kind of color-coded with some additional metadata on top of it that tells you where are the bottlenecks, which steps are taking more time, which steps are taking less time, or which steps are more frequent or less frequent, and so on. So, for example, this is a typical example of what a tool such as Apromore will be able to give you out from via performance mining. It will tell you that, for example, in here, I have a bottleneck. The transition between this step and the next step is taking close to 22 days. If I want to improve the cycle time of my process, I should probably be focusing on these 4 bottlenecks, which are all around the same step in my process. Process mining tools also allow you to see, sometimes side by side, the process map and some performance dashboard that shows you, for example, which activities takes more time or are more frequent, or what is the average execution time of my process, instances, and so on. The 4th operation that process mining provides us is called variant analysis. Variant analysis is a very interesting thing because it takes as input 2 event logs, event log 1 and event log 2. Typically, these are 2 variants of the process. For example, imagine I have an insurance claims handling process that is executed in 2 different regions or in 2 different countries like Estonia, Latvia, and Finland. And as an insurance company, I am very interested in trying to understand why is it that in Finland, the process is a little bit slower than in Estonia, and which is a little bit slower than in Latvia. What are Latvians doing that is just makes their process run faster relative to how it runs in Finland or Estonia? Or I might have an event log of containing customer issues like customer complaints, and some complaints are resolved to the satisfaction of the customer and some are not. And I would like to compare these 2 variants of the process to understand why is it that in one case I am resolving the complaint and in the other one I am not. Now, for example, a typical scenario where we see process variant analysis being used is to compare cases that finish on time versus cases that finish late, and to see what are the differences. And very often we see people saying, wow, I see what the difference is. In the cases that are slow, there is a certain loop that is being taken that is not being taken in the fast cases. So we should try to see what are the root causes of this rework. So those are the 4 operations that process mining provides to us. I'm going to kind of piggyback into that another type of operation which classically is not known, it's not considered to be process mining, but that is very related to process mining, and it is called predictive process monitoring. Predictive process monitoring is an operation that allows you to find out, while a given process instance is running, in the middle of the execution, how will that process instance finish? Will it finish on time with respect to a certain deadline? Will it finish late? Will the customer complain when this process instance finishes? Will the customer not complain? But unlike process mining, the process mining is very post-mortem analysis and is meant as a tactical management tool. Predictive process monitoring is meant to be about more real-time or near real-time analysis. I'm trying to look at the process instances that are currently being executed and make predictions about when will they complete. Naturally, these predictions are done using machine learning models. So predictive process monitoring tools, which typically are integrated into process mining tools like Apromore, provides both process mining and predictive process monitoring, allow me to answer questions like, what will be the next activity in this case? When will it happen? Who will do it? How long will it take until this case is finished? What is the remaining time of this case? What is the outcome of this case? Will the customer complain or will the customer be satisfied? Will we pay a compensation in the case of an insurance claim, or will we not, or we won't pay a compensation? The way predictive process monitoring works typically is that from my database system of my enterprise system, I mean that from the database of my ERP system, be it Dynamics or SAP or ServiceNow, I will extract an event log. The same type of event logs I described before, absolutely no difference, except perhaps that there are some attributes that tell me something about the outcome of the process. Like, for example, did the customer complain or not? Was the customer satisfied? Did we finish on time or not, etc. And from that event log, I will build, using machine learning techniques, a predictive model that I will deploy, and at runtime, I will feed in an event stream from which I will generate different types of dashboards. I might generate a detailed dashboard that for every ongoing case tells me when will it finish, and marks as red those cases that will be late, and green those that will be on time, or yellow those that might be late. Or I can derive aggregate dashboards. Like, for example, this is an aggregate dashboard we came up with a logistics company where they can see for every region, for every type of product or type of shipment, they can see what percentage of shipments will be late or will be on time, etc. So it's like an aggregate predictive dashboard. Or I can use these predictions and associate them with rules and generate alarms. That is something we call prescriptive monitoring. So predictive monitoring is about predicting how the case will finish, and prescriptive monitoring is about triggering actions that, or interventions we call them, or treatments that when applied to a given case will reduce the chances that it ends up in a negative outcome. For example, if a case is running late, I will increase its priority, or I will assign it to a special case manager so that we can finish it on time. And in that way, we avoid violating our service level objective. So when I associate a predictive model with some set of actions, and I use certain techniques to link them, we call that prescriptive process monitoring. So I have finished the part of the presentation that related to what is process mining. In the following, I will talk more about why we need process mining. What does it enable us within an organization? At University of Tartu, we have been studying this question in our BPM group, and we have adapted an existing framework for business process management to the field of process mining. And we have derived a framework that we call value-driven process mining. And value-driven process mining tells you that any process mining project you undertake will have one of the following 5 primary drivers. The first driver is transparency. Transparency means that we use process mining to discover the process, to see how it looks like. And that is done by means of automated process discovery. So I take an event log, I discover the process, and I explore the process in order to find things that might be happening or might not be happening. So at this stage, I'm going to be switching between presentation and demo in order to make this much more concrete. So if I am in a project where transparency is the driver, where what I want is to discover how the process is being executed, then I will use mainly automated process discovery techniques. I will show you how this works on the Apromore open source product. So if I am not mistaken, you are seeing the screen of Apromore. And Apromore, when you log into it, so it's a server-side software, it's a web application, you log into it, and when you log into it, you see folders, and you see 2 types of files. So one type of file is a process model, and I can potentially even open that process model and start editing it as I wish. So I can start, it doesn't look very nice, so I can start laying it out in a way that I like it. And the second type of file is an event log. Let me show you where does these event logs come from. So we typically run certain tool sets that will extract For example, a CSV file, a comma-separated file from an enterprise system. And this comma-separated file might look, for example, like this one. I will be using one that comes from the field of manufacturing, because that's one of the topics that is covered in the InnoCape project. So an event log, this event log that I'm going to use for my demo today, looks as follows. There is a case identifier that corresponds to a work order, naturally anonymized for confidentiality reasons. So originally this was a work order ID, but we just replaced them with case 1, case 2, case 3. The second column tells me what work was performed, what step of the process are we talking about. The steps in this process are tasks performed by machines in a production line. For example, turning and milling, which is performed by machine number 4, or laser marking, which is performed by machine number 7, or lapping, or round grinding, or final inspection for quality control. These activities involve certain resources, the machine itself, and somewhere here I will find also more difficult to find, but somewhere here I find the worker who was operating this machine when this particular work order was handled. And I have timestamps, and in this event log I have the start timestamp, which tells me when did the work order started this step, and end timestamp, which tells me when did we complete this step for this particular work order. I can import this event log, which I already have done previously, and I get an event log in my Apromore workspace, which I can share with other people within my organization. When I open that event log, I will see immediately a process map, and the process map shows me what steps are performed and how frequently these steps are being performed. Very importantly, process mining tools allow us to see our event logs at via process maps at different levels of details. In here, I am not seeing the entire set of possible steps and transitions. I'm seeing a filtered version of it. We have found that in practice, when you extract data about your process and you try to visualize it, your process looks like this. It's a complete spaghetti, because in real life, things happen in all sorts of directions. Different work orders take different routes in my production line. Different loan applications go through different exceptions, and I have to do a lot of rework left and right. In a hospital, in a patient handling system, I will have patients circulating in all sorts of directions through my different laboratories and other departments of my hospital. So the first thing I need to do as a process mining analyst is to find what is the right level of abstraction for my process model. And there is a point where I am happy, so I use the sliders above to determine at what level of detail I want to see the process. And once I have determined at what level of details I want to see the process, I might want to see where are the decision points, where are the parallel branches, where are the rework loops. For that, any process mining tool, such as Apromore, will allow you to switch between the process map view and the BPMN view. And in the BPMN view, we will see the process with the decision points, the frequency of every branch in a decision point, the rework loops. Like, for example, I might have, if I increase the level of details, I will start finding that here at the beginning of the process, there are different rework loops. You see, I do this task, and sometimes I repeat it, and I can even see specifically how many times I repeated. And by applying something called filters, which I will talk about later, I could even try to focus on those instances of the process where this repetition or this rework occurred. And by doing this, by inspecting my process at different levels of details using the various zoom in and zoom out functionality that a process mining tool like Apromore provides you, you will be able to discover lots of things about your process that sometimes you didn't think were even possible. So we find people saying this is not possible, but then we show them the data and they have to admit, yes, it happens. And then they can go to this specific set of cases and they can retrieve their case IDs, and they can visualize like the particular cases where the problems happen and the different performance statistics of that case. And they can trace things down to specific steps that should not have been performed, but that were performed, and trace down who did them and start some interviews to be able to find out why are we doing certain things that we shouldn't be doing. All right, so that is the first driver of process mining in our value-driven framework. Process mining allows you to achieve transparency via automated process discovery. The second driver is efficiency. Process mining allows us to find the bottlenecks, the constraints, and the sources of waste in our business process that we can then start tackling by means, for example, of lean methods. So to illustrate that, that is achieved by means of three operations in process mining. A process model enhancement, so we can enhance a process model with performance information. Log animation, we can animate the process on top of the process model in order to see where the bottlenecks build up and how they build up. And performance dashboards, which allow us to see statistics, like performance statistics about my process at different levels of details and in different slices and dices. Let me illustrate to you what that means in this process. So here, I'll go back to the process map view. Here I have a process. I find the right level of abstraction for it. And let's say I want to find what are the bottlenecks. So process mining tools with a single click will allow you to figure out for every task how much time it takes. And for every transition between these two types, how many hours or days or week it takes on average, or you can get minimums, maximums, cumulatives, medians, all sorts of other statistics. And in this way, I am able to see, for example, that one of the tasks, the machines that is the slowest, is machine number 16. And maybe that's not something I was expecting. Or, for example, one of the biggest bottlenecks is between churning and milling and nitration. That probably means that you can see nitration only takes 26 minutes, but I have to wait 1.44 weeks to go there. So as a production engineer, I might determine that this is completely normal, because before nitration, you need to leave things for 1 week waiting. Or I might say, no, this is not natural. We could speed up the process by trying to make the transition from milling to nitration a bit faster than we are currently doing. I can even see how many, not only which bottlenecks. So here I see I have a bottleneck, but then I find out, this thing only happens 4 times. And my process has about 225 cases. So, well, it only happens in about 1% of the cases. So it's not a big deal. You know, maybe, yeah, indeed, this is a bottleneck, but it's not a bad bottleneck because it's very infrequent. On the other hand, somewhere here, I have some other waiting time of 2.5 days to laser marking, which is very frequent because laser marking is done 167 times or in 167 of 225 cases. And therefore, maybe I should be focusing on making this step, laser marking, a little bit faster in terms of waiting times. So another thing you can do with process mining is that you can start computing performance charts. Like, for example, I can take this log and I can create a dashboard out of it. So dashboards in process mining tools allows you to see, for example, the statistics of how much time different case takes. So I can see that, hey, some cases are taking more than a month. I did not expect that. This is, or even more than 2 months. This is something we need to deal with. It's not normal that it's taking that much time. I can also see which activities are being performed, how frequently are they being performed, what is the relative duration or the total cumulative duration of these activities, so that I can see in which particular tasks I should be focusing if I want to improve my process. I can also see the statistics by resources or by any other attribute that is present in my event log, be it by worker, by parts, etc. Different types of parts that are manufactured, etc. So by doing this, we can investigate the bottlenecks in the process and the opportunities for improving the process from the perspective of efficiency. Now, the third driver of process mining is quality. So we see several projects where we do process mining to improve customer service, to reduce defects. And that is done by means of filtering and model comparison, by means of multi-log animation, and by means of comparative dashboards. So let me show specifically what kind of things you will look if your primary driver is improving quality. So in this particular process, I can observe that there are sometimes some defects. And these defects, I can see them because they cause me certain reworks. Parts get bounced back from quality control. And this is something that a Six Sigma person will immediately go and try to investigate using a variety of techniques. Process mining gives additional techniques to the Six Sigma expert in order to investigate and identify all the issues in their process. So, for example, in here, I can see there is rework. So I can split the log by means of so-called filters into those cases where rework occurs or those cases where there's no rework does not occur. So in Apromore, you can filter by means of many criteria. You can filter, for example, in such a way that you retain only those cases that takes less than a month. And separately, you can retain only those cases that take more than a month. Or you can filter by only those cases where a given task, so for example, final inspection, which is sometimes executed up to 33 times in this process, you can focus on cases where final inspection is happening 3 times, which means that that part bounced back 3 times and that we had to do 3 times the final inspection. So if I apply this filter, I will see only those cases where the final inspection was executed 3 times or more. If I save this log, which I can, and put it back into my workspace, I will be able then to separate those cases where rework occurred, where a lot of rework occurred, and those cases where no rework or only a normal amount of rework occurred. And I can then open these two things in 2 different windows and compare them. And I can see, for example, which machines are involved in those cases. On the left-hand side, I have the no rework, rework, and on the right-hand side, the no rework, and I can see which machines are involved in one case and which machines are involved in the other case, and I can find out, there is this machine in here, which is, let's say, very frequently involved in rework cases, 13 times, and that is not very frequently involved in cases where there is no rework. So maybe I should be investigating what is happening in this machine number 4. So that's a hint that this tool is giving me. The other way in which I can compare 2 event logs and do variant analysis is by selecting them and putting them together in a dashboard. We call that comparative dashboards. In a comparative dashboard, you will see color-coded 2 different variants or subsets of your process. Blue are the cases where no rework occurs, and red are the cases where rework occurs. And I can see immediately, as I might have expected, that the cases where no rework occurs are faster than those cases where rework occurs. Mostly all these cases that take more than a month are cases where rework occurs, in fact. Whereas all the cases that takes less than half a month are cases where no rework occurs, which is maybe something I expected. I can see which activities are more frequently executed in those cases where there is rework versus those cases where there is no rework. So those places where red is above blue means these activities are performed more frequently when there is rework or no rework. Another thing I can do to do to analyze the quality or the defects in a process is to do multi-log animation, which means I take a process model, which I have automatically discovered from the event log. I take those cases where there is rework and those cases where there is no rework, and I create a log animation out of them. And in a log animation, it's going to basically allow me to replay all the cases at an accelerated speed. And I'm going to see blue dots are those where no rework occurs, and red dots are where those where rework occurs. And I can see where the bottlenecks are built up, where there is more red, where there is more blue. And in that way, I can build up a case that probably I should be focusing on these particular parts of my process if my goal is to reduce the amount of rework. Sorry, I'm having a problem with my mouse. Okay. The fourth driver that we see in the field of process mining is compliance. And compliance can be analyzed in two ways via process mining tools. One of them is by means of rule-based filtering, and the other one is by means of conformance checking. So let me give you a very quick overview of how that looks like. This time, I'm going to take an event log of a purchase-to-pay process. In a purchase-to-pay process, there are a lot of different types of compliance rules that you need to follow in order to avoid fraud. This is a log extracted from an SAP system. And in there, at some stage, we create an accounting document. And later, on that basis, we make a payment. And there is one rule that frequently needs to be enforced called the 4 eyes principle that tells me that these two tasks need to be performed by different people. So I'm going to check that by means of a filter. I'm going to create a filter in which I'm going to retain only those cases where accounting document is executed, and after that, somewhere after that, I made the payment. And I'm going to focus on those cases where the same resource, same username, is the same user is performing this task, and that task is doing the accounting document and making the payment, which shouldn't be the case. And I will find out that this happens sometimes. It happens specifically in 63 cases out of 35,000 cases, so it's not very frequent. And I can see exactly what are the pathways that can lead to this violation of compliance. I can even switch perspectives and put myself, for example, instead of looking at the activities, I can start looking at the users. And I can see which specific users are involved in these cases where there is a violation of this 4 eyes compliance rule. The second way in which you ensure compliance with process mining is by doing something we call conformance checking. Conformance checking means that I take a process model and an event log, and I ask the tool to compare them. So in Apromore, you will select the process model. This is a process model of a loan application process, and the event log, and you will compare them. And when you compare them, you get something like this. You get the process model on the right-hand side, and you get the list of differences between the event log and the process model on the left-hand side. And if you click at one of these differences, it shows it to you. And in here, I'll be able to see, if I do a little bit of a zoom in, that in some cases, I am skipping the task check credit history, which normally I should do. And instead, I am just appraising the property and assessing the loan risk without having checked the credit history before. And this is happening in 10% of traces. With filtering, I can then go back and investigate those cases where this activity is being skipped and figure out who is involved in those cases, and then investigate this compliance violation further. And the fifth value that process mining enables you to do is agility. And it enables you to do by means of at least two operations. One of them is change analysis, which I will not show due to lack of time, where you take an event log that spans multiple years and you find out at what points in time the process has changed. And then you can analyze the changes and then determine, why the process has changed in a way that we did not expect it to happen. When does the demand, when does a certain activity become more frequent or less frequent than before, which might signal that, we have had to react to some new type of customers or new types of products. The second way in which you can achieve agility via process mining is by means of predictive monitoring. You can build predictive dashboards that tells you how the case, what will happen with the case in the future, and you can use that to trigger alerts that will trigger interventions in order to react to exceptions in your process or to potential SLA violations in your process. Predictive process monitoring is a topic on its own. It involves training machine learning models, deploying those machine learning models, streaming them. So I'm not able to fit that in such a short amount of time. In future, we might have a separate webinar dedicated to it. But just to give you an idea, what predictive process monitoring, for example, in Apromore allows you to do is to create dashboards such as this one, where for every case that is currently ongoing in a process, you are able to see which activity was last executed, when did it happen, how much time has elapsed since the start of the process, what is going to be the next activity if the case has not completed yet, and when will this particular case finish, on what particular date. You can also predict what is the remaining time. You can also predict what is the possible outcome. Will things be granted or not granted? Of course, this requires us to be able to train machine learning models and validate those machine learning models before we deploy them in order to ensure that they are sufficiently accurate for the needs that we have. And with that, I kind of cover the 5 value enablers of process mining in our value-driven process mining framework. Apromore is a 10 years old project, so we are having our birthday precisely this month of April, and that motivated this webinar. Since we first started developing the open source kernel, which was initially a process modeling tool and then became a process mining tool. And we have engaged in a number of projects with different companies through University of Tartu, through University of Melbourne, through our separate company. And we have been able to apply Apromore across the full spectrum of values that I have told you. We have helped government agencies who care a lot about transparency to analyze their procurement processes. We have helped manufacturing companies to analyze movements of different work orders throughout their production lines by extracting data from the manufacturing systems. We have worked with insurance companies, analyzing their claims handling process, for example, and analyzing differences in performance across different regions. With telcos, who usually care, or banks, who usually care about compliance, finding anomalies, violations of compliance rules. And with logistics companies working on the agility driver in order to, for example, predict late shipments, predict shipments that are erroneous, incorrect, or incomplete, and be able to act upon them in advance. To conclude, I would like to say that process mining should never be seen as a discipline on its own that will solve your process improvement problems. Process mining is like a wrench. You use it as part of a broader toolkit. When you do process mining for transparency, you will do it in conjunction with process modeling and enterprise architecture. When you do process mining for efficiency, you typically use it in conjunction with lean methods. When you do process mining for quality, you typically use it in conjunction with Six Sigma or other quality management frameworks. When you do it for compliance, you couple it with governance, risk, and compliance frameworks. And when you do it for agility, you couple it with agile enterprise frameworks like, for example, SAFe. So process mining enhances these other disciplines. It does not replace it. So process mining does not really tell you how you should improve your process. This is something we're currently trying to investigate, is how can we automatically improve the process. But for the time being, what we have, state of the art, is process mining that allows you to enhance existing methods and not replace them. Finally, I would like to say that everything I showed, you can go and try it yourself. Apromore is available, has 2 editions. Community edition is purely open source. It's free, unlimited. You can download it. It comes as a so-called Docker image. You get your IT people to install it in a server in your organization, and you can start playing around with it. And we know dozens of organizations as we speak that are just doing process mining with Apromore Community Edition. The commercial edition, Apromore Enterprise Edition, is also available in a 90 days trial, and that one is hosted. So it's a software as a service. You don't need to install everything. You just sign up for the trial, and you get into a cloud instance where you can start doing all your analysis. And the event log I use in today's demo is a production log. It's a log that is publicly available. You can download the CSV file from here, and you can upload it either into the community edition of Apromore or into the enterprise edition. And of course, we, the Apromore team, we can be found at apromore.org. You can find there a forum where you can ask questions and we will answer for you, where you can get a lot of other resources, including user manuals, video tutorials, and so on. So I encourage you to go and give it a go and become hands-on. So with that, I will start having a look at the questions now, as soon as I find the chat window. Great. So the first question I see comes from Olga Lucero. She said, do you have cases where you have used process mining to make decisions about business processes that are not viable or profitable, to be able to use this type of analysis to know which products or services give the best or worst profits to the companies? Well, we have done process mining to analyze costs and to find what we call cost sinks. So in the same way that we can annotate the process model with these performance measures like time, we can annotate them with cost. And then we can see what parts of the process are consuming the highest amount of cost. If you wanted to also have a notion of profit, what you need to do is when you pre-process the data before you bring it to your process mining tool, you can add a concept of cost, how much revenue an instance gives you versus how much it costs you. And then you can analyze the process in terms of cost. You can, for example, zoom in into those cases that are not profitable. So that's how we can tackle this kind of cases. We don't have specific experience where the goal where we have started with a process that was not profitable, but we have had a lot of experience where the goal has been to reduce the cost of the process by identifying cost sinks and trying to reduce them, or identifying types of cases that cost much more than the others and trying to mitigate those. David says, my question would be, are you looking into ways to extract insights automatically, like a suggestion, look at machine 5, it included reworks, occurs, etc. Right, yes, we have a project on called PIX, which is the Process Improvement Explorer. PIX is the next tool we plan to develop after Apromore, and PIX will be able to upload an event log and to find all sorts of recommendations for improvement. What you mentioned is something we can achieve already with process mining by applying templates, meaning that we go and we look for rework loops, we go and we look for bottlenecks, and we just list them to you in a big report. Or you should look at what machine 5 is doing because it takes too much time, or you are reworking too much in here, etc. So that is already possible with existing process mining technology. But in PIX, we want to go further. What we want to do is to say, for every type of problem, there are certain actions you can take. For example, if you have a rework, you might want to start to introduce a verification step in order to avoid the rework later. If you have a problem of a task, a business value adding task that adds value to the business but not to the customers, like verification, and it's costing you too much or delaying your process too much, you might want to make the verification offline and to replace case-by-case verification with statistical control. And what we want is to encode into PIX a whole range of possible process improvement patterns, and then to apply them automatically through the data and compute not a big list of possible changes, but even like a set of optimal changes, Pareto optimal changes, we call them, that improve your process with respect to multiple performance. The technology is not there. Tools that produce a listing of stuff that you could have seen in the screen yourself, of course, they exist, but tools that can actually link find Pareto optimal sets of changes with respect to your process, that is something that does not exist. And one of the reasons why, one of the bottlenecks to get there, David, is that we need a tool to be able to accurately simulate the effect of a change in the process. And in our team, we are developing that tool. It's called CMOD, S-I-M-O-D, CMOD. And if you type it, it's a tool that you give it an event log and it computes a simulation model out of it. It then simulates, you can then make a change and it will simulate the change for you. And it will accurately be able to take what is the effect of that change. So before we can really do what we call automated process improvement, we have to solve the problem of how can we compute highly accurate simulations to do what-if analysis purely from the data without requiring you to give a model, which by all means will probably be incomplete, because when we model a process manually, we do not draw all the possible pathways. No, you cannot try PIX, but if you type CMOD, then you should be able to land into a page where you can try out CMOD. And it's currently just a Python tool. It's not very easy to use. But if you want to do a pilot case study at the University of Tartu, we are always very happy. Our PhD students love to engage in pilot studies where they try out their tools in cooperation with an industry partner. Ernest, what about the relation with adaptive case management, e.g. police work? Can it lead to real-time performance support of the involved knowledge workers? Predictive process monitoring is very useful indeed in the context of case management. You see, in predictive process monitoring, we don't care about the process model. We don't need to have a set of pathways. We discover the predictive model strictly from the event log. So all we need is from your case management system to export the records of cases and their state transitions into a CSV file. We load it into our predictive monitoring tool. We build machine learning models on top of it, and we are able to give you predictive performance dashboard that tells you which cases are going to be running late, which cases are going to cause a problem, etc. And that allows, in conjunction with certain rules, to give you some better idea. Exactly, you can couple it with business rule, as you said yourself, Ernest, and do what we call prescriptive process monitoring, right? Do you have cases, so this comes from Olaolu, do you have cases where process mining is used in regards to policy and regulations compliance, especially in the public government sector? Example, compliance with procurement policies. The case where I was showing you, where I took SAP procurement data and I started to check the 4I's principle, that is a very typical type of case study in which we engage. So, and it's generally either banks, telcos, or government agencies that engage into this type of compliance-driven process mining projects. Generally what we do is that we go through their GRC, their governance, risk, and compliance type of templates, and we translate those into rules. We encode those rules into the tool, and then you can apply those rules, those filters, and check if any cases, for example, in the past month, have violated certain compliance rules. So yes, it is a very, one of the 6 types of projects that we observe out there. Are you looking into integrating process mining with robotic process mining, i.e., yeah, absolutely. So we have done something called robotic, we have coined a term called robotic process mining. I mean, I'm not going to claim I'm the only one. There are many other vendors that do something called task mining. So task mining means I take logs of user interaction. So we record 4 hours of someone working on top of their computer on a certain task of a process, and we analyze it in order to identify the patterns that this person is following, or maybe not one person, but maybe 10 different workers, and we identify different patterns and the relative performance. We find standardized ways of performing the task. and we find opportunities for automation. So the state-of-the-art, commercial state-of-the-art in task mining is at that level. So we use process mining as a tool for doing that. We are going to send the slides and the video recording on Monday or Tuesday. When I send the slides, I'll make sure I add a link both to CMOD that I mentioned before, but also to our RPA logger, which does exactly what you said. It records what you do as a worker, and then it allows you to export that into CSV files that you can import into Apromore and visualize your tasks. What our research group is going to do is to develop a new type family of tools that not only identifies how different people perform a task, but that identifies automatically a way of performing the task, not only the sequence of steps, but all the data transformations that you do. For example, when you are copying things from Excel into a browser, and automatically generates a UiPath script that you can execute straight away in a UiPath bot. So we are going all the way from a recording of 4 hours of someone doing work to 1 or more UiPath bots that can then replicate certain subsets of the work that this person has been performing for those 4 hours. That is still in a research lab, and we expect that during the second half of this year, we're going to be launching a relatively mature prototype that can go all the way from recording you in Excel or browser to UiPath bots. And we expect that process mining vendors will then, including Apromore, will pick up this technology and ship it to you perhaps starting next year. Does a predictive dashboard exclude explanations for its predictions? It is a very good thing to have explanations for predictions indeed. What many tools allow you to tell you is for every case, what are the features that make that the tool gave you that prediction. So perhaps the tool will tell you, it is because task A has been performed more than twice that the case will end up late. Note, however, that this is a correlation rather than a causation, but at least it gives you some explanation. At least it tells you what features are involved in that prediction. Not that I know of existing tools, but of course, using interpretable AI frameworks like Sharp Values or Lime, you could go a little bit further and quantify the impact of every feature on a given prediction. Not that I have seen it yet in predictive process monitoring dashboards or out there, and it's not a feature we currently have in Apromore, but definitely something that we need to integrate. Correct. I think that we are more or less at the end of the 1-hour session we had scheduled. As I said before, and as it's written now in the chat window, we are going to send the slides and the recording, and as a caveat, I will add these links that I mentioned in response to the questions so that you are able to look at the research we are currently doing in automated process improvement, data-driven simulation, and robotic process mining. Thank you very much, everybody of you, for joining. It was a pleasure to have you here, and we hope that we are going to be organizing this kind of webinars perhaps once a month at least. So just stay tuned through the same channels through which you found the advertisement for this webinar. Okay, thank you very much, everybody. Bye.